Okay, so first thing is to get any kind of information we can get out of this function itself, right? So let's do like x-intercept. X-intercept is going to be clearly 0 is 1, right? We can tell better if you factor out 2 over 3. You get 5 minus 2 x exactly. So it's going to be 5 over 2, so another x-intercept. Right, 5 over 2. So I mean, when x equals 0, of course y is also equal to 0 too. So this actually is the origin, right? So, and that's the other x-intercept. So I don't need to find the y-intercept because I already have it right there. Okay, and does it have any symmetry? I don't think so. Okay, end behavior, right? End behavior. As x approaches to infinity, that's always approaching positive infinity because of that square on the top. So when it's approaching infinity, it's minus. This is minus infinity, right? Because it's 5 minus 2 times infinity. Yeah, so that's, we're going to approach downwards as we approach right. And then when we approach minus infinity, this is going to be still positive infinity, but this is going to be positive infinity, so y is going to be positive. Okay. Now, let's do the first derivative. So 5 times 2 over 3, that's what? 10 over 3 x to the power of negative 1 over 3. 10 over 3 again, x to the power of minus 1, you get 2 over 3. You can factor out 10 over 3 as well as x to the power of negative 1 over 3. And you get 1 minus, you add 1 over 3 to this, and you get x. This is 10, 1 minus x all over 3x to the power of 1 over 3, right? Okay. So the critical numbers is x is equal to 1 and 0. Okay, 1 and 0. And I want to know when this is positive. Okay. It's going to be positive when 1 minus x over x is positive, because x and x to the power 1 over 3 will have the same sign. Yeah. This is going to have the same sign as 1 minus x multiplied by x, because whether you divide or multiply, it's the same. Furthermore, I'm going to multiply this one by negative 1, so I get a nice parabola, but this has to switch. So when it's negative, meaning 0 and 1, in here, so the function is increasing when it belongs to 0 and 1. Okay, so just keep that in mind. We're gonna fill in the box later. I mean, yes. Okay, so here's 0, 1. What did we originally solve? We solved this one, right? This is the derivative of g. Where's the derivative of g greater than 0? In the process of trying to solve this equation, this inequality, I got negative because I had to multiply both sides by negative 1. The answer to this is clearly here, right? But that's when it's going to be positive. Okay, you have to watch out for that. Okay, so this is undefined. This is 1. Anyway, we're gonna put this box. We're gonna combine this box with the second derivative box later. Okay, so let's do the second derivative. Let's keep the 10 over 3 out, and I'm gonna do a quotient rule. So minus x to the power of 1 over 3. 1 minus x. Differentiate that, and you get 1 over 3 x to the power of negative 2 over 3. And you gotta square the bottom, so you get 2 over 3. Okay, what can we factor on the top? Well, we can factor out 1 over 3. You can also factor out x to the power what? 1 over 3 or negative 2 over 3? The smaller exponent. Always. Okay? Because what you do in reverse is to add that exponent to these exponents, right? So if you add 2 over 3 here, you get just x. Of course, this is just gone, right? If you add 2 over 3, it's just 1, right? So now we can clean up. This is 10 over 9. This can come under as x to the power of 2 over 3, so we get 4 over 3. And we have a minus x and a plus x. So it's minus 1, right? Alright, so we get minus 10 over 9 x to the power of 4 over 3. This is going to be always negative. Always negative. Because this is negative, this is always positive, right? This is actually not bad. This is a well-made question, basically. Okay, so we have g prime, g second prime, we have 0, we have 1, we have undefined, 0, always negative. This is positive here, negative, right? Okay, so here it's going down, down, like this. This is up, down. So look, it's gonna be a cusp here. Okay, and then down, down, right? This is a local max. So these 2 points, 0 and 1, you need to find out what they are. At 0, it was actually the origin. It was 0, 0. So usually you put the y value here, in this last column. And the local max, 1. So let's go back and plug in 1. What do we get? We plug in 1. It's 5 minus 2 is 3. Okay, so here. At 1 it's 3. So it's going to do this. And intersects, the x-intercept was what? 5 over 2, so 2.5. And it's got to do this, right? And the end behavior matches. Minus infinity, positive infinity.